and get the meeting started. Hello everyone, and welcome to the BBSim and Scalability Brigade for April 23rd, 2020. We have 3 points on the agenda. The first two should be fairly quick, while I expect some discussion on the third one. Before getting started, just a very quick reminder that the call is recorded, so be mindful of what you share online. So, the first point is a very good news. Kent and Ken spent some time last week debugging the issue that was causing flows, that was causing port discovery nonus to be delayed. They pinpointed it down to a particular commit, and the issue has now been resolved. If we go look at one of the plots, we can see that the delta between the discovery of the news and the discovery of the flows, it's very, very small. Now, if you have looked at the builds lately meaning this morning, you may notice that there are some that failed. All of them failed for the same reason that was a down in GitHub. So when the build was trying to download this particular file, it was failing because GitHub wasn't responding. I checked the times with the build, and GitHub was actually going up and down at that point. So we'll just need to wait a little longer, and the builds will come back to green. The second point is that we have the first run at scale that check the flows. There are a few issues that John is investigating in the Golang version of the agent. In particular, there is a mismatch between the length of the actual OpenFlow message and the length that is calculated. And so that goes on us to disconnect the device, because that's considered a fatal error. But then it recovers. So we're looking at that to fix it, but we are having the first result. We're now waiting for the news to be enabled in Volta, then waiting for the ports to be discovered in ONUs, and then back to Volta, waiting for the flows to be programmed in the logical device, and waiting for the flows to be acknowledged in ONUs. Because of what I was saying before, the acknowledgement in ONUs is not too reliable yet, so these times may be completely wrong. That really depends when the device disconnects or connects, because that seems to trigger the success in the test, but then the flows actually go back to pending that state. So that is still under investigation. Anyway, I will say that it's a pretty good number down in Volta, because we are pushing, in this case, 200 flows, and that happens barely 20 seconds later than when the ports are discovered in ONUs. And I believe that this can be improved, but remember that there is a polling delay in ONUs of 5 seconds, and a polling delay in the test itself of 5 seconds. So this number may be a little shorter or longer. Anyway, you can see now that we are collecting all the information in the plot. So we have in red the discovery of the new devices in Volta, in yellowish green the discovery of the ports in ONUs. And then in purple, the flows in Volta, and in blue, the flows in ONUs. Is there any question on this new test?
What's really the difference between the time in ONUs flows and Volta flows? Is it the change from pending add, for example, to added? Is that what it is?
Yeah, so in ONUs, we are checking, so in Volta, we are just checking that the flows are pushed down. I'm looking at the temperature. Okay, so in Volta, we're just checking in the logical device flows that the total number matches what we expect. For now, we are testing using the AT&T configuration because that's the quickest one that will give us some flows to verify. And we'll get one equal flows per each uni plus one LLDP flow for the NNI. We'll get some more at the moment. We'll turn on DHCP. Anyway, once all the flows are present in Volta and the logical device, then we switch to checking ONUs for the flows that have been successfully acknowledged, and so they go to the added state. And this may take a little longer, but this is where we see that length calculation mismatch in the OpenFlow agent.
Okay, I see. So the first check is really that the flows get into the core, and the next check, it's after those flows has been decomposed and sent to the adapters, and ONUs does the next stats on the flows, and then some of them are added. I think that's where the difference in time is. Okay, that's fine.
Yeah, that makes sense. I'm expecting to see a little bit of difference in time, but not this much, because the biggest issue here is that at a certain point, you see that some of them have been added, and then suddenly none of them have been added. And then we go from 0 up 16, 27, back to 0, 48, 35, and then 200 done. But if you go look at the artifacts of that build, at the list of the flows that is collected at the end of the build, some of them went back to pending that state. And we took a quick look yesterday, and this seems to be because the WF agent connects and disconnects from ONUs, and that confused things a little bit.
Okay.
Okay.
Is it useful to collect the statistics on when the flow actually added to the device? So if the owner says the flow is added, that means the flow is actually added on the device, then that's fine. But if it's not that, then it's useful to also plot how much time it actually takes to add the flows on the device.
Yeah, I can check in BBSim, because BBSim has an option to keep track of the flows.
Yeah, that would be very helpful, because the added, all it means, it has been added in the core, and the core has decomposed that and sent that to the adapters.
Yeah, and this is particularly interesting because the adapter also does a lot of processing with the DB to get the pond resources, and there are a lot of routines running there.
Yeah, absolutely. I'll get in touch with you, Girish, to understand how to convert the flows, because I know that one flow in ONOS doesn't reflect in one flow to the LT, but it may be more than one.
Yeah, actually one flow, okay, one decomposed flow is one flow on the device.
Yeah, but I need to know how many to check.
Okay, okay. Sure.
Okay, but I thought the core added meant more than just that the core had decomposed it and sent it to the adapter. I thought you wait till the adapter acknowledges something,
Yeah.
right?
Yeah, that's what I understood, because the recent changes that Andrea did to, report success or failure, that actually meant that the device flow was added. So I was not, so that's why I was asking the first question. So if when owner says the logical flow is added, that actually means that all the decomposed flows also have been added on the device.
I doubt it. Let me check. I'll get back to you right away.
Yeah, sure.
I mean, the change that you made for scale was that you won't wait till the adapter had acknowledged it to process the next flow. So you would process flows in parallel, but you will still, for a particular flow, still wait for acknowledgement before you report it back to ONOS as added.
Actually,
I don't think it will wait for an ACK from the adapters, but it will need to send an actor to ONOS before, otherwise you won't be able to process flows in parallel.
So if I remember correctly, the deal was that the moment in which the adapter acknowledges the flow, we tell ONOS that everything is fine. And then if something went wrong, we were sending another OpenFlow message to ONOS saying, no, actually something went wrong with that flow. That was a flow mode update, I think.
Yeah, that is also what I would expect the behavior to be, and what I saw in my latest edition of the code base. Basically, what there is a callback that happens from the adapter that tells the system that something went wrong. It throws an error message, but that error message is on the physical device flow. That physical device flow then gets remapped again to a logical device flow that gets thrown as an error to ONOS. So, but the added state is as soon as the flows get into the logical device, if I'm not mistaken. So, Ken, you're right.
So this may explain the behavior that we're seeing, because when the device disconnects and reconnects, then ONOS push down all the flows. All the flows are acknowledged at that point, and the tests succeed because they are passed. Then something else goes on. I have no idea what, I haven't investigated yet, and the flows are reported back as pending.
Yeah, that's my suspicion too.
If we need to make a change, to wait until we get a positive ACK from the adapters, meaning that everything is completed, that's a very tiny change in the code to do that. And if we want to try that out, I can make an image just for that case and
so
try that out.
If I remember correctly, the issue with that was that when we do that, we don't report the success back to ONOS in time, and so ONOS tries to push the flows down again, and we enter in this loop in which we are just putting more and more stress into the system.
I think you're right, Theo. There is a timeout after which ONOS for pending add flows try to re-add them because it expects the device to be capable of dealing with that flows under that timeout. We could look at possibly extending that in ONOS. I think it's a possibility if we want to go down this route of getting the ACK.
Do we know the value of the timeout?
It's a good question. Let me check.
We can find it. I don't know if that's is the same value at which we are polling for flows, then it's 5 seconds. Because that will set it up this flow start interval.
The timeout is probably double that.
Yeah. Let me check.
So the acknowledgement in ONOS is done via statistics, right? That is what I know.
Yes,
So,
that is correct.
Yeah, so it should be 5 seconds. So that is probably because Theo sees different intermittent times between the flows pending and flows add.
Yeah. That will totally explain this behavior. But
I'm saying the timeout is probably twice that, but I could be wrong. I mean, Andrea's checking. So I don't think we need to change any behavior unless it's, starting to cause problems.
Yeah, no, I think we need to investigate this a little more, because what we need to figure out is why later on the flows are reported as pending gap. Because I think it's fine to say almost, okay, I got the flow, everything is fine, don't worry about it. And then we just report if something went wrong. Now we just need to figure out why something is going wrong.
But I thought you said there were issues in OF agent disconnecting, which could explain that, right?
That will explain why the test at a certain point sees all the flows as updated. It doesn't explain why the flows are timing out and being reported at pending gap.
Okay.
So anyway, before jumping in and making changes, I will take a couple more days to investigate this and figure it out. This is a job that I just started running yesterday. We had basically from 6 to 11 of the meaningful build, because these were just to tune the pipeline. We had 5 builds, none of them with the backlog. So I'm gonna look into that a little more today and see if I can come back with some more details.
And these are just for the EAP flow insertion time, right? You are not programming any subscriber from the ONOS.
No, not yet.
Yeah, okay.
So in general, the approach we are trying to take is add something to the test, tune it, and then move forward. So it's not hard for me to add a call to provision the subscriber and do all that stuff. But I don't think there is much point until we solve this issue with the flows. If there is any desire, it shouldn't be too hard to add that to the pipeline and see what happens.
Just to give some perspective on the flow thing. So locally, I run some local testing. Basically, it's really like there's nothing that run in a container. It's just it's a unit test that run usually on the core only, and using a bunch of mocks for the OLT and ONUs. And if I tried with 1,500 ONUs, like all mock devices, and as soon as I enable them, and as soon as ports get created, I send some flows. I think there's one flow per ONU and maybe a couple of them to the OLTs for each port. What I have in terms of numbers, and that's just pure core, for flows, to be able to send all the flows and all those flows on the mock OLT and ONUs, For 1500 ONUs, I think it was taking around like 300 seconds total. This means like all those flows was sent and decomposed and sent all the way to the ONU and OLTs. Again, in a mock environment.
Okay, so that is the pure time that the core is taking.
Yeah, exactly.
To that, we'll have to add the time that the open-onu adapter.
Exactly. Yeah. So again, this is just mock environment. So if, it means it's like locally it looks not that bad. So I'm sure with all the changes that we have done lately, it should even be better than that.
So you think 1500 flows took 300 seconds?
No, it's more than 1500 flows because it's 1500 flows for 1500 ONUs, so one flow per ONUs. And then there was also a lot of flows that I think like triple that amount to OLTs. And this 300 seconds, this is like basically what I had in my environment. I enable an OLT that has 1500 ONUs. So during that time, as soon as a point get created, a logical point get created, I'm sending a flow down. So this is like this 300 seconds that you're seeing, this is really the time of enabling ONUs and sending flows out. So it's not just purely just the flow decomposition per se. It's the entire time that after 300 seconds, I'm seeing all the flows and all those devices has been enabled on their ONU.
Okay. Well, just to give you some kind of a comparison, when working with switches and flow programming on switches, not OLTs, not Volta, not anything. But our experience has been that it's reasonable to expect about processing about 1,000 flows per second. It's on the higher end. Maybe it's, sometimes it's 600, sometimes 800, sometimes 1,000. Some other devices do a lot better job and can do more than 1,000 flows per second. So the number you told me, I think, okay, so it's done on the mock devices. It also includes activation time, right?
Yeah, that's
but
correct.
From a pure flow programming aspect, I mean, it would be good if we can achieve somewhere near the numbers that we get from switches. We can do 500 a second or 1,000 a second. That would be good. But we don't have to flow program a lot, because once we have programmed the subscriber, not much happens. It's just that when all the subscribers are coming in at the same time, the thundering herd problem. That's when we really need to program a whole bunch of flows at the same time. So for that scenario, I think we should try to see if we can get closer to the switch performance when seen with ONOS.
I wanted to give a perspective of where we are at this time.
There also will be a difference because ONOS is taking the flows and pushing down to the device. Volta is receiving some flows and changing them in something that ONU and OLT can understand. So it's going to be hard to arrive to the 1,000 flows per second.
Okay, let me.
Yeah, I don't doubt that, but sorry, go ahead.
Sorry. Some perspective from our tests we're doing in Türk Telekom environment. We're also pushing a lot of flows to Volta for our scaling test. I don't know if you know, but in Türk Telekom workflow, there are about 10 flows per subscriber when subscriber provision. So 1,500 means 150 subscribers. So when we're testing for about 400 or 500 subscribers, we're going to 5,000 flows. And this generally takes about time between 5 or 10 minutes in our environment. So I think this is a bit big value. And what we saw in our test, the reason of that is because we are trying to add all of the flows to a logical device, and it's kept in data model in a logical device, and it's locked for adding or changing the status of these flows on the same logical device. So it takes too much time to add all of these flows, because it's just like adding all flows one by one in the system. So one flow is taking the lock of the logical device and going to add it to the system, and then release the logical device lock, and the second one takes the lock after this. So it takes a lot of time to add this much of flows on the system. What we're trying to do, we're exercising to take these flows out of the logical device in the data model. And same thing applies also to the device itself, because there's also a device in the Volta data model. And for OLT device, it's only a one OLT device for all the subscribers. And so the thing that happened for logical devices also is happened for device itself. So we're exercising to say separate these flows from logical device and device in data model. And if we can see some differences in there, we were planning to bring it to your interest and discuss it on this call. But still, it's very primitive in our test. So this is case for our tests in our labs. So I wanted to bring this to your interest for decision discussing.
Yeah, thanks. I think it's clear we need improvements, maybe not to the point where I was talking about 1,000 flows per second or even 500 flows per second, but clearly there is a room to improve at least 5x from say the number that you're giving Mahir. And we need to get there. So we've just started doing flow programming based scale tests. So we just need to work through the issues to get to that point.
Yeah. Okay.
Timeout is always 5 seconds. Sorry, I was just checking the timeout. It seems it's always 5 seconds, the poll frequency. And there is no timeout longer than 10, meaning that it's always 5. It always polls for 5. That's the state normal one.
Okay, thanks.
Thanks, Andrea. Is there anything else on the flow provisioning topic? Okay. So the last point that we have on the agenda today is the replica deployment model for the ONU adapter. As you probably noticed, today we are deploying multiple. Example. We are actually creating multiple deployment of the new adapter, and that is a little tricky to manage when we're talking about scale. So this is the example. These are pods actually running in different deployments and the deployments are called open-onu -1, 2, etc., etc. This means that when you want to scale up and down, it's tricky because you're managing multiple deployment, and it's not really the way you should scale up things in Kubernetes, because you should just have one deployment and scale up the containers within that deployment. Now, the reason for which we went down that way is that the adapter is not really stateless, and we need to bind devices with adapters. And we do that by passing a startup flag to the containers that is called current replica, and it's defined in the engine. Now, we only need that to uniquely identify an adapter. So any value that doesn't change across reboots, scale up and scale down will work for us. Unluckily, as far as I know, at the moment, there isn't a way to pass the replica ID into a running pod. I did some investigation. So we need to figure out something else. It seems like there is this tool that Kubernetes offers that is called the downward API, in which you can read information from the pod into environment variables. But as far as I can tell, at least looking yesterday, we had a brief discussion in Volta. There is this issue in Kubernetes that asks exactly how to have this pod ordinal label. But this needs to be tested. If this can work, then our change will be very, very simple and just on the Helm charts. If not, we should make a time benefit assessment and decide whether to change this model or not. So is there anyone that has any idea on how to address this issue?
I found that the link that you showed, this is like an improvement of getting the ordinal number, but we should be able to get it from the pod name if we pass the pod name. It's not an elegant way to do that, but it's I believe in the pod name we should be able to, that ordinal number will be part of it. But this so what you're showing is this is more an elegant way of actually getting the ordinal number directly. And that's in the next release, right? Or is it already available?
So it's unclear, because I read somewhere that I think it was at the bottom of this issue or somewhere else that it will be available in Kubernetes 1.19. But we can try this, because this seems to be working. But, we'll see. This seems to be a pull request that is still open. So.
Okay.
Another solution for this problem could be using the stateful sets or replica sets. Well, when I check the Kubernetes documentation, when you check the replica set documentation, they are saying that you should use deployment, you should avoid using replica sets. If you need some replication, use multiple deployments instead. And for when I check the stateful sets documentation, the documentation says if you need any identifier that persists, Then stateful sets, you can use stateful sets. So maybe we can check using the stateful sets for this problem. But as far as I see from the documentation, it says you need to have a headless service to make to have a responsible pod that identify the different pods. So we will have one additional service for this purpose if we want to decide the stateful sets.
Yeah, I can take a deeper look into that and basically see if I can figure out a way to get that ID without creating too much of a mess around it.
Maybe we are doing the right thing right now. We don't know. So
yeah, it just seems seems a little strange to me, but it's also true that this is not a traditional service that you will scale, because all the example I've seen about scaling is for pure stateless services.
yeah.
So in that way, it's super easy to scale them up.
Yeah, correct. And we will need the same for multiple OLT when we want to deploy multiple OLTs. So we need to have multiple RV cores and multiple OLT adapters. So,
but do you need to have multiple cores and multiple OLTs in the same stack?
yes.
Or,
I think that is the HA plane currently we decided, right?
well, that was the original plane as far as I can tell, but then at a certain point we did the simplification of one OLT per volt, and now we're exploring if we can get a little more out of a single core. But I still thought that the long-term plan was to have multiple stack talking to the same monos cluster if we wanted to go to a big number. But sort of maybe you have some more insights in this.
Yeah, that's still the plan. So what was the question, actually?
So the question is, currently we are deploying multiple ONU adapters for one OLT. So when we have multiple OLTs, we need to also deploy multiple RV cores and multiple OLT adapters.
Yeah, so that's a separate stack, but it's still in the same Kubernetes cluster. Is that what you're trying to say?
Yes, correct.
I mean, logically, it's a separate stack, right? One stack has got nothing to do with another stack because they're dealing with different OLTs, but it's still the same Kubernetes cluster. So the question is on the deployment of the cluster itself.
So I think in that case, it's a different deployment. It may even be a different namespace. It may be some different identifier. So we're not really scaling it up and down. We're deploying a new copy of it.
Yeah, and if we're trying to just keep isolation, again, this might go forward a little bit more. But you know, if we can put everything in one pod, and then we don't have to worry about trying to have a separate namespace for each stack.
Yeah, but that will mean.
Sorry, go ahead.
I was thinking that putting everything in one pod will make the scale thing very, very complex, because you'll need to basically redeploy to add or remove an adapter. And that may be fine for now, not sure.
I didn't quite get all that, but.
So how do you scale up or down a single container within a pod? I don't think you can do that via the Kubernetes API. You can scale up or down the pod.
Yep, you scale up or down the pod. You'd have to, I'd have to look in to see if you can add a container to a running pod. Because I mean, the problem is you're managing namespaces for each stack is going to get real complicated real quick as well.
Yeah, agreed.
But Theo, when do you need to scale up and down a container within a pod?
Well,
our
for example,
deployment is static, right? Yeah, go ahead.
Yeah, for now it's static. I don't think it's right to make all the deployment infrastructure so that it will be static forever.
I'll take a look in that today to see if we can dynamically change the number of containers. But again, if I'm deploying everything in a pod, then when I deploy an OLT, I know how many ONUs it has. You might just be setting that pod up for what that OLT has, right? So it may not be an issue of trying to scale up a pod because it is configured when it started for a specific OLT.
Yeah. The number of ONU subscribers might change over time.
But there's going to be a physical limit.
Yeah, there's a max, and
well,
you would know.
So you deploy for the max, yeah.
Yeah. I'd have to, again, we can look to see if we can scale up a set within a pod or not, but if not, you scale for the max.
What about Kafka? Are you going to deploy a separate Kafka for each stack, or only single Kafka for all stacks?
Well, it gets interesting if you put everything in a pod.
Yeah.
Then you could potentially start, and again, if you're not load balancing, using Kafka for load balancing, this goes again forward thinking. You start using gRPC. You don't have to deploy Kafka. There's not a per anything deployment of Kafka.
But the current implementation of multiple ONU is on Kafka feature. So I think if we continue with Kafka, and if we use, say, a single Kafka for multiple stacks, then we will probably need some identifiers again for all of the entities, all of the modules in the system. So we will face with this problem again when we try to deploy multiple stacks.
Yeah, but so if you're using Kafka, you can configure the topic, the core, and adapters use. So there is no problem theoretically in running multiple stacks in parallel, as long as you configure correctly the topics and they don't overlap.
I can start a documentation around this topic. I already started thinking about the issues that we may face when we start deploying multiple OLTs. So maybe going through a documentation could be good. What do you think?
Yeah, I think start investigating that would be great if you want to take it on Serkan. That's great. Then we can see where to go from there.
Okay.
Okay, so is it fair to say that David will look a little more if we can deploy everything in a single pod, while Serkan looks at how we can deploy different stack on the same cluster, and I take a look at the stateful set thing on the adapter, but before taking any concrete action, we'll discuss it again here next week.
Yep.
Sounds like a good plan.
Okay. Cool. Is there anything else we need to discuss today?
So Ralph, is this topic going to be on next week the today call?
So it's a good point. In next week's, there are 2 days, right? So this is day 1, where we have more than 100 people signed up for it. So the topics are going to be more high level. And we're trying to hear from a bunch of different operators and so on. The day 2 is sort of, we expect a smaller group, less than half of the day 1. And there are some topics that have already come up, like device management, that we need to talk about more. So if you want to talk about scale, I had planned on talking about scale, but I wasn't exactly sure what do we talk about. So when you say this topic, then can you tell me what you have on your mind?
I'm thinking more about the entire deployment of Volta in whether single pod or multiple pods in order to meet the, I believe DT was talking about 2048 ONUs, right?
Yeah, I mean, all of that, before we have some numbers to justify what we are saying, some server sizing, Kafka sizing numbers, etcd, how much CPU memory we are using. It's kind of really just guesswork that we are, yeah, we can use single stack. Yeah, we can use multiple stack. And I'm afraid till next week, we're not going to have those numbers to justify going in one direction versus another.
Yeah, makes sense. So I guess we need to do some more legwork on that one before we actually figure out.
Yeah, what I what I can say is that we do need to get past the flow programming things that is sort of the last remaining piece of the puzzle. And if we can get past the flow programming part and optimize that to the point where we feel, okay, yes, we are comfortable now doing it, say for 1 OLT and 1,000 ONUs, then we can start exploring the things related to sizing, right? And then we can make some conclusions. Okay, if we have a single stack, then this is, on a server of this kind with CPU and memory of this kind, this is the consumption we are seeing for 1 OLT with 1,000 ONUs. And then we can start making those calls. Okay, in a deployment, let's say you're going with 5 OLTs, but not maxed out, right? In 5 OLTs, but not 5,000 ONUs. We're going with 5 OLTs and maybe 500 ONUs spread across those 5 OLTs. At that point, do you need multiple stacks? Well, no, maybe not, right? Maybe you can start off with a single stack, knowing what our single stack needs are. And then as time goes on and you're filling more and more ONUs into those 5 OLTs, okay, at that point you make a decision, okay, now I'm going to move this OLT over to another parallel stack that I'm going to create on the same Kubernetes cluster, right? So, because, on a single stack, I'm getting closer to my limits. So we start migrating to multiple stacks at that point. So, but these are all decisions that, these are hand wavy and not conclusive and isn't backed up by data of any kind. So any discussion we have next week is still going to be like that because we haven't really gone through that exercise. And that exercise, I'm hoping, is what, by the time we release Volta 2.4, which is end of June, we will have far greater clarity on with numbers backing up our decisions.
Yeah, makes sense. You're right. We're not there yet.
Yeah, especially another thing that we need to look at is why the jobs for 500 on you and 1,000 in you are not very stable.
Yeah. So nevertheless, I mean, I can schedule on day 2 sometime for us to have at least give a technical update on, you know, what we have gone through, where we are, and then outside of this group of say 10 of us, if other people have questions and comments, then, you know, that would be good to address, or at least hear people out to see what they are saying. But yeah, so I think that would be that. For that, I can at least schedule sometime in the agenda for day 2.
Yeah, I think giving some kind of status report to the broader community will be good, or at least say describe where we're thinking of going, what are the thing we're looking at now. I'm not sure we're ready to make decisions yet.
Yeah. And on day 1, I'm going to give a very small status report. I mean, because we don't have a, I mean, we've gone through this exercise over the last 3-4 months to work on scale, and we've made a lot of progress. But so I'm not going to say much on day 1.
Okay. I think with this we have covered everything. So if there isn't anything else, we call the meeting done.
Hi, Matteo. Yeah, can I ask a couple of questions? It's
Yeah, sure.
Marika from Reply. So yeah, we are doing some scalability tests on the T environment here in Berlin, but we are facing some problem. So just to give you a bit of context, we are using the 8 adapter of the new with the MIB patch, and basically the last version of Volta, it should be kind of the lastest because we merged everything yesterday, so everything should be fine. But we are facing actually 2 problems. One is related to the ACDC container. So it seems that at some point basically crashed because it consuming so much memory, and we don't know why, as well as the DB itself. So I don't know if you have encountered this problem before or not. I just want to understand if you have some idea why we can have this problem.
So just to make sure I understood correctly, one is the etcd container that restarts.
Oh yeah, I didn't mention the other one, sorry. The other one was the onus, and basically also the memory goes up on the east side, and since we are not using the latest version of it, I was also wondering if the last change that I saw was made 20 days ago, it's a major one, or we can just skip it and keep going with the onus that we have?
No, I think regarding onus, there is nothing major that has changed in the apps from a performance point of view.
Okay.
There are a couple patches that are solving issues when you run multiple OLTs.
Okay.
Because otherwise programming flows doesn't really work if you bring up the OLTs at the same time. Regarding etcd, I haven't seen that issue myself. I know Serkant saw it, and there is a way in which I think you resolved it by increasing the memory restriction that Kubernetes gives.
Yeah, we did that. Still, it doesn't work. That's why I don't know. We're trying to figure.
There is another parameter related with the DB. I don't remember the exact name right now. It could be DB backend size or something. I can't find and send. So probably it is too small.
Okay,
like 128 megabytes. So you need to increase that size.
Okay, yeah, we will try to do that. Okay, cool. I mean, that's for now. And thank you.
Just Marika, in general, I don't know if you are on Slack or not, but we have a Slack channel that is called BBSim that we use to discuss scale and emulator issue. So if you have issues, just join the channel and we're there every day, all day.
Okay, cool. Thank you very much. Thank you again.
Sure. Okay. Is there anything else? I'll take that as a no. So thank you everyone for joining today's call, and talk to you soon.
Thanks, Joe. Bye.
Thank you.
Thank you. Bye-bye.
Goodbye.
Bye-bye.
Thanks, Theo. Bye.